2 Boeing 747s. 1 runway. Sikfog. 583 people would die in the next 60 seconds. Neither aircraft had left the ground. The 27th of March, 1977. Tenerife. It is still the deadliest accident in aviation history, and it happened because of a single word spoken on a radio that meant 2 different things to 2 different crews. These are the 5 deadliest accidents in the history of commercial flight, ranked by lives lost and by the rule each one left behind. Before we begin, one thing needs to be said plainly because it changes the list. This is a ranking of accidents. It is not a ranking of the deadliest days in the air. 2 events killed more people than anything you are about to see, and neither of them appears here. The attacks of September 11th were not accidents. Air India Flight 182, which went down off the coast of Ireland in 1985 with 329 people aboard, was destroyed by a bomb. Those are security failures, and their lessons belong to a different story. What follows are the 5 worst accidents in the history of commercial flight. Failures of metal, of procedure, of language, and of judgment. And each one of them ended with a rule. Every one of these 5 accidents changed something concrete about how aircraft are built, repaired, flown, or spoken to. That is the thread running through this entire video. Not the loss. What the loss bought. We will count down from 5 to 1. And the further down we go, the more you will notice something uncomfortable. In almost every case, somebody already knew. Number 5. The 19th of August, 1980. Riyadh, Saudi Arabia. 301 people. Saudia Flight 163 was a Lockheed L-1011 TriStar, a wide-body trijet, one of the most advanced airliners of its generation. It lifted off from Riyadh in the evening, bound for Jeddah, with 301 people on board. 7 minutes after takeoff, warning lights indicated smoke in the aft cargo compartment. The crew turned back. And here is where this accident separates itself from every other accident on this list. The airplane made it. Flight 163 returned to Riyadh and landed successfully. It rolled out, turned off the runway. It came to a stop on the taxiway, intact, upright, with 301 people alive inside it. And then nothing happened. The engines were not shut down for another 3 minutes. No evacuation was ordered. The crew had reported that they were ready to evacuate, but the order was never given and the doors were never opened from the inside. Emergency crews reached the aircraft, but the doors were designed to be operated from within, and the cabin was still pressurized, which meant the doors physically would not move. 26 minutes after the aircraft came to a stop, ground personnel forced the right second door open. By then, the fire that had begun in the cargo hold had burned upward through the cabin floor. The autopsies are what make this accident so difficult to read about decades later. Every single person on board died of smoke inhalation. Not one of them died of burns. They were gone before the door opened, inside an aircraft that had landed safely, sitting still on the ground, at their own destination airport. The investigation could not determine what started the fire. The origin was placed in the aft C3 cargo compartment, and an early theory about a passenger's portable stove was examined and found unsupported by evidence. But the cause of the fire turned out to matter far less than what happened after it. There is a design question underneath this accident that took the industry years to answer honestly. Cargo compartments on airliners are classified by how a fire in them is expected to be handled. Some classes assume a crew member can reach the fire. Others assume the compartment is sealed tightly enough that a fire will consume the available oxygen and smother itself. That second assumption depends entirely on the compartment staying sealed and on the contents not supplying their own oxygen. A fire that burns through the ceiling of the compartment is no longer sealed. It is being fed by the cabin above it. And the first sign the people in that cabin have is smoke coming up through the floor. The rule this accident left behind is not one rule but a family of them. Fire detection and suppression standards for cargo compartments were tightened, and the classes that relied on a fire smothering itself were progressively pushed out of passenger aircraft in favor of compartments with active detection and suppression. Flammability requirements for cabin materials were rewritten. And most importantly, the decision to evacuate was moved to the very front of crew training and stripped of hesitation. A modern crew is trained that an evacuation decision made too early costs money, and an evacuation decision made too late costs everything. Flight 163 is why that sentence exists. It is also why cabin crew today are authorized to begin an evacuation on their own judgment if the flight deck has gone silent. The authority to open those doors no longer sits in one place. Number 4. The 3rd of March, 1974. The forest of Ermenonville, north of Paris. 346 people. Turkish Airlines Flight 981 was a McDonnell Douglas DC-10, climbing out of Orly bound for London. 335 passengers, 11 crew. Many of the passengers were traveling because a strike had grounded another airline, and this flight was the one with seats left. 12 minutes after takeoff, at around 12,000 feet, the rear cargo door separated from the aircraft. What followed took 77 seconds. When the door left, the pressure in the cargo hold dropped instantly while the cabin above it was still pressurized. The cabin floor was not designed to survive that difference. Collapsed downward. And running through that floor, as they did on every DC-10, were the control cables to the tail. The crew still had engines. They had almost nothing else. 77 seconds after the door failed, the aircraft struck the forest at close to 500 miles an hour. There were no survivors. At the time, it was the deadliest accident in aviation history. Now the part that makes this the hardest story in this video to tell calmly. The failure mode was not a surprise. It was not a freak event. It had been identified in 1969, before the DC-10 entered service. It was reproduced deliberately in ground testing in 1970, where engineers watched the cargo door fail and the floor collapse exactly as it later would over France. A subcontractor's engineer wrote an internal memorandum warning that this door would eventually open in flight and would probably result in the loss of an aircraft. That document is known today as the Applegate Memorandum. And then in 1972 it actually happened. American Airlines Flight 96 lost the same cargo door over Windsor, Ontario. The floor partially collapsed. The crew, through a combination of skill and luck in how the damage fell, landed the aircraft. Everyone survived. That was a free warning delivered 2 years early, with no cost in lives. No airworthiness directive was issued. The fix was handled through an arrangement between the manufacturer and the regulator rather than through a mandatory order. Service bulletins went out. The aircraft that crashed near Paris had a latching mechanism whose locking pins had been filed down, which allowed the handle to be forced closed while the latches were not actually engaged. The rule this accident left behind was written in 2 parts. The cargo door latching system was completely redesigned so that a door cannot indicate locked unless it is locked. And separately, and far more importantly for every aircraft you have ever flown on, floor venting became a requirement. Modern airliner cabin floors have vents so that a sudden pressure difference equalizes through the vents instead of collapsing the floor onto the flight controls. There is a second rule, and it is not written in any regulation. It is the reason the phrase known risk carries the weight it does in aviation engineering. After 1974, a documented, reproduced, predicted failure mode could no longer be managed quietly. Number 3. The 12th of November, 1996. Charkhi Dadri, in the Indian state of Haryana. 349 people. Saudia Flight 763, a Boeing 747, had just left Delhi and was climbing. Kazakhstan Airlines Flight 1907, an Aviation IL-76 cargo aircraft, was inbound to Delhi and descending. They were using the same corridor because at that time Delhi had one, shared between arrivals and departures. The controller cleared the Saudia flight to climb to 14,000 feet. He cleared the Kazakh flight to descend to 15,000. 1,000 feet of vertical separation, which is the standard and which is enough. The Kazakh aircraft did not stop at 15,000. It continued down through its cleared altitude into the block of air the Saudia 747 was climbing into. The two aircraft met head-on. Investigators focused on the cockpit of the IL-76. The crew's English was weak. They did not communicate with air traffic control directly. A dedicated radio operator relayed instructions to the pilots. When the controller mentioned the Saudia aircraft at 14,000 feet, it is considered likely that this was heard, relayed, or understood as their own instruction. There was no collision avoidance equipment on board either aircraft. There was no secondary surveillance radar at Delhi providing the controller with automatic altitude readouts. The controller had no independent way to see that one of his aircraft was 300 meters below where he had put it, until it was too late for anyone to do anything. It is worth pausing on how thin the margin was. 1,000 feet of vertical separation between two aircraft closing head-on is, in time, a matter of seconds. Neither crew was doing anything reckless. The Saudia crew were exactly where they had been told to be. The controller had issued a correct and standard clearance. Every element of the system worked except one, and the system had no way of noticing that the one had failed. India's response set a global precedent. The country mandated collision avoidance equipment for every aircraft operating in Indian airspace, the first mandate of its kind anywhere. That system, which we now call TCAS, does not ask air traffic control for permission and does not depend on anyone's English. Two aircraft carrying it negotiate directly with each other, machine to machine, and instruct their crews to climb or descend in opposite directions. It is one of the few safety systems in aviation that works entirely without words. It works by having each aircraft interrogate the transponders around it and build its own picture of who is nearby and where they are going. If two aircraft are projected to come too close, both systems talk to each other, agree which one will go up and which will go down, and then tell their crews. The instruction is not a suggestion. Crews are trained to follow a resolution advisory immediately, and to follow it even if air traffic control is telling them something different at that moment, because the two aircraft have already agreed with each other, and the controller has not been part of that conversation. Delhi's shared corridor was separated into distinct inbound and outbound routes, and the amount of airspace under exclusive military control was reduced. Secondary radar was installed, and the question of language proficiency in the cockpit, which had been an uncomfortable subject for years, became something the industry could no longer avoid. Formal English language proficiency standards for pilots and controllers on international routes followed, with required testing and periodic reassessment. Number 2. The 12th of August, 1985. Mount Takamagara, Japan. 520 people. Japan Airlines Flight 123 was a Boeing 747, registration Juliet Alpha 8119, on a short domestic hop from Tokyo to Osaka. It was the height of the Obon holiday season and the aircraft was nearly full, 524 people on a flight scheduled to last under an hour. 12 minutes after departure, at 24,000 feet, the aft pressure bulkhead failed. To understand what that means, you have to know what that bulkhead does. It is the dome of metal that seals the back of the pressurized cabin. Behind it is the tail, which is not pressurized. When it ruptured, the cabin's air rushed backwards into the tail section all at once. It tore off most of the vertical stabilizer, and it severed all 4 hydraulic systems. The 747 has 4 independent hydraulic systems specifically so that no single event can take all of them. This event took all of them. Within seconds, the crew had no rudder, no elevators, no ailerons, no spoilers, and no functioning landing gear controls. They had 4 engines and a control yoke connected to nothing. They flew for 32 more minutes. Using engine thrust alone, pushing power up on one side to turn, pulling it back to descend, the crew kept a crippled 747 in the air over central Japan for half an hour. What they were fighting has a name. An aircraft without working elevators still wants to hold a speed, and when it is disturbed it trades altitude for speed and back again in a slow cycle, climbing and descending in long waves that can take a minute or more each. It is called a phugoid, and adding thrust to climb makes the next wave larger, not smaller. There is no intuitive way to stop it. Every instinct a pilot has trained for makes it worse. They fought it the entire time. At the end of those 32 minutes, the aircraft struck a ridge in the mountains of Gunma Prefecture. 4 years later, the crew of United Airlines Flight 232 lost all hydraulics in a DC-10 over Iowa, in a very similar situation, and got their aircraft to a runway at Sioux City using the same thrust-only technique. 185 of the 296 people on board survived. That crew had trained for it, informally, on their own initiative, partly because of what had happened in Japan. For people survived. All 4 were women seated toward the rear of the cabin. The cause was found in a repair carried out 7 years earlier. In 1978, this same aircraft had struck its tail on the runway during a landing at Osaka. The aft pressure bulkhead was damaged and had to be repaired, and the correct repair called for a single continuous splice plate secured with 3 rows of rivets. The technicians used 2 separate plates instead of 1. On one of the plates, only a single row of rivets did any real work. Investigators calculated that this reduced the repaired joint's resistance to fatigue cracking to roughly 70% of what a correct repair would have given. Then the aircraft went back into service and was pressurized and depressurized, once per flight, 12,318 more times. The crack grew a little with each cycle, invisible from the cabin, until the 12th of August 1985, when it grew all the way. This remains the deadliest accident involving a single aircraft in the history of aviation. The rule it left behind concerns how repairs are certified and inspected. A structural repair to a pressure vessel is no longer a job that ends when the aircraft flies again. Documentation, independent verification, and long-term inspection of repaired structure were all tightened. Japan Airlines went further than regulation required and built a permanent safety promotion center at Haneda, where wreckage from this aircraft is displayed, and where every new employee of the airline is taken. Number 1. The 27th of March, 1977. Los Rodeos Airport, Tenerife. 583 people. Neither of these aircraft was supposed to be in Tenerife that day. Both were bound for Gran Canaria, and both had been diverted after a bomb was detonated at the terminal there. Los Rodeos was a smaller airport, and it filled with diverted wide-bodies until aircraft were parked on the taxiway. That detail matters because with the taxiway occupied, an aircraft that needed to reach the start of the runway had to taxi along the runway itself and turn around at the end. That procedure is called backtracking, and on that afternoon both the KLM and the Pan Am 747 had to do it. Then the fog came in. Visibility collapsed. The tower could not see the runway. Neither aircraft could see the other. Los Rodeos had no ground radar. There is one more pressure worth naming, because it explains the urgency without excusing anything. Dutch duty time rules had recently been tightened, and the penalties for exceeding them had become personal and legal rather than a matter of company discretion. The KLM crew were approaching a hard limit. If they did not depart soon, the aircraft and its passengers would be stuck on Tenerife overnight. The captain also chose to take on a full load of fuel while waiting, a decision that added time on the ground and added weight that would matter very much in the last few seconds. The KLM aircraft backtracked, reached the end, and turned to face down the runway. The Pan Am aircraft was still on that runway behind it, looking for a taxiway exit it could not clearly see in the fog. The KLM captain advanced the throttles. His first officer transmitted that they were, quote, at takeoff. The controller replied with the words okay, then stand by for takeoff, I will call you. At that moment the Pan Am crew also transmitted, saying they were still on the runway. The Pan Am transmission and the controller's transmission reached the KLM aircraft at the same instant. On a radio, two signals on one frequency do not arrive as two messages. They interfere. What the KLM crew heard was a squeal, and out of the whole exchange only the word OK survived intelligibly. The KLM flight engineer asked whether the Pan Am aircraft was clear of the runway. He was told that it was. The takeoff continued. The two aircraft became visible to each other with a few seconds remaining. The KLM captain pulled up hard enough to strike his tail on the runway. The Pan Am crew turned to leave the pavement. Neither maneuver could finish in the distance available. 583 people died. 61 survived, all of them from the Pan Am aircraft. Everyone aboard the KLM aircraft was killed. It remains the deadliest accident in the history of aviation, and both airplanes were on the ground. There was no mechanical failure. Both aircraft were serviceable. What failed was language, and the assumption that everyone in the exchange meant the same thing by the same words. So the industry changed the words. The single largest phraseology reform in aviation history came out of this accident, and you can hear it on any frequency today. The word takeoff is now spoken only in the actual clearance, cleared for takeoff, or in canceling it. At every other point in the conversation, crews and controllers say departure instead. An aircraft cannot casually announce it is at takeoff, because that phrase no longer exists. Acknowledgements change too. Roger and OK are no longer acceptable responses to a clearance. The key elements must be read back in full, so that the controller hears what the crew believes it was told. And a clearance issued to an aircraft already lined up on a runway must be prefixed with the words hold position. There is one more legacy, and it is the largest of all. The KLM captain was the airline's chief of flight training, one of the most senior and most respected pilots in the company. His flight engineer raised a doubt about the Pan Am aircraft and did not press it when he was answered. The industry looked at that dynamic and concluded that a cockpit which cannot be contradicted is a cockpit with one point of failure. The response is called crew resource management. It formalizes the idea that authority does not make a person correct, that a junior crew member is obligated to speak up, and that the captain is obligated to listen. It began as an idea after Tenerife and became mandatory training for airline pilots worldwide. It is now taught outside aviation entirely, in operating theaters, in power stations, in any room where seniority could stop somebody from saying something is wrong. 5 accidents. 1,899 people. Look at what actually caused them. One airplane was destroyed by a door that a company had already been warned about in writing. One was destroyed by a repair that was signed off and then forgotten for 12,000 flights. One was destroyed because 2 crews and a controller did not share enough language between them. One was destroyed by a fire that the aircraft survived and the evacuation did not. And the worst of them all was destroyed by a misunderstanding about a single word, between 2 crews who had done nothing wrong except assume they had been understood. Not one of these was an act of nature. Every single one was something a human being could have caught, and in several of them someone did catch it and it was not enough. That is the uncomfortable part. But here is the other part, and it is the reason this video exists. Every one of these accidents was answered. The door was redesigned. The floor was vented. The repair rules were rewritten. The collision avoidance system was mandated. The word takeoff was taken out of the language. The evacuation decision was moved to the front of training. And the cockpit stopped being a place where the captain could not be questioned. Commercial aviation in the 1970s killed roughly one passenger for every 200,000 flights. Today, on a modern airliner with a trained crew, you would have to fly every day for tens of thousands of years to expect to be in a fatal accident. That did not happen because flying got easier. It happened because the industry has an unusual and rather grim discipline. It treats every accident as a permanent instruction, writes the answer down, and makes it mandatory for everybody. These 5 accidents are the reason a great many people who are alive today are alive today. That does not make them less terrible. It is simply the only thing that could be salvaged. Every claim in this video comes from official investigation reports and their public summaries, and the sources are listed in the description. If there is an accident you think we should cover, leave it in the comments. The next investigation on this channel gets chosen from there.